Okay, the argument here is simply this. We evaluate this in an almost identical manner to the way we evaluated this. We write down our P's and Q's and our truth values, and we write down our argument, and then we write down the antecedent, which looks a whole lot like the antecedent here, except that we have a not P here where we had a not Q here. So here's our antecedent for the argument, and our consequent is not Q, as opposed to up here where it was not P. Now, is that going to make a difference? We've changed our Q here to a P, our P here to a Q. Maybe we just made an interchange of meanings of P and Q. Is that going to affect the truth value of the argument? Yeah, it turns out that it does, as we'll see. Okay, we take the we have again a conjunction of if P then Q, which we put here, and not P, which we put here. And we also wrote down our not Q, and we wrote that down before we wrote either of these down, because of course not Q is our consequent. I should put an underline under there. I mean, I did have something like an underline there, but it looks like a bar over the F. Okay, well, either way, we now have all the columns labeled that we need, so that each column can be labeled by looking at one or two columns to its left. We don't have to look at more than two things. We have only a single rule to apply in evaluating each column. Okay, well, our first column is not P, so we reverse the values of P. And you can check to see that that's the case. Then we do if P then Q. Okay, the rule is again, as long as P isn't true and Q false, it's going to be true. We do have P true and Q false, antecedent true, consequent false here, making the statement false, but in every other case that's not so, and every other case therefore is true. Okay, not Q, we reverse the values of Q. Now to evaluate this, we look at the if P then Q column and the not P column. In order to make this conjunction true, both of these statements have to be true. Well, that happens here as well as here. So we have two cases where this conjunction is true, and then we have two cases where it's false, because in this case the not P is false, making the conjunction false. In this case neither is false, making the conjunction false. Okay, now this conjunction of course is our antecedent. In this row and this row the antecedent is false, so that the conditional can't possibly be false. If your antecedent is false, then it doesn't matter whether your consequent is true or false. The conditional is true. Now, the one case where the conditional is false is if the antecedent is true and the consequent is false, and that's exactly what we have here. Here's our antecedent, it's true. Here's our consequent, it's false. So in this third line, we find that the argument runs false. In the fourth line, it's easy to see that the argument is going to be true, but we have proven that the argument is a fallacy. There is a case, a way to make this argument false. There's a way that the argument doesn't hold. And if the argument doesn't hold in every possible case, then it's a fallacious argument. It's not true, it's not valid. Now, I do suggest, if you're having any trouble with this, that you write this, this, and this without writing any truth values, and then fill in the truth values from left to right. Start by filling in your truth values for P and Q. You should know how to do that. I think everybody does, but just to be sure, you should fill it in. Fill the whole thing in, then compare with what you see. Don't try to memorize what I've written down here. Just fill it in and check. Do the same here. Many people appear to need the practice on this, and I can't do more than explain the process. You're going to have to get this straight, and that's a really pretty good strategy for being able to get it straight. You also need, of course, to understand how to take an argument and put it into a single statement. Then you need to understand that unless you have all truths here, the argument is a fallacy. If these are all true, the argument is valid.